Hello everyone, welcome back to my channel codeWithKhan. Let's see today's LeetCode problem. So it is 3010, divide an array into subarrays with minimum cost. So you are given an array of integer nums of length n. The cost of an array is value of the first element. For example, cost of 1 to 3 is 1. So it is the first element of that array. And cost of 3 for 1 is 3. So this for this array 3 is the cost. So we need to divide nums array into 3 disjoint contiguous subarrays. So for given nums, so we need to divide this nums into 3 contiguous subarrays. Okay, so this is one subarray, right? This is one subarray, this is another subarray, this is one subarray. So we need to so order doesn't care here, and length also that we don't care about the length too, right? So we just need to return the minimum possible sum of the cost of this subarrays. So once we divide this nums array into 3 contiguous subarrays, so we need to find its minimum cost. Okay, now let's see the constraints. Constraints are very small, so we didn't care about the time complexities. Now let's see one example. Okay, so if you clearly observe in the question, so we need to divide all the elements into subarrays, right? So the subarray should be non-empty, right? So subarray should be non-empty. That means, so if we want to include this first element into the subarray, so what we can do, we can create this one subarray, or we can create with this one, or we can create with this one. We cannot go further, because if we go further, like we cannot, we also want to create 2 more, right? Further, at least we need 2 elements. So we can create a first subarray with these 3 elements. So what did you observe? If you have a single element, or if you have a 2 elements, or if you have 3 elements, always the minimum cost of this subarray is going to be the 0th index of the nums array. So to include these number, right, the minimum cost of this subarray is going to be nums of 0, right? So there is no way to include, we cannot exclude, because we need to divide the nums into the 3 subarrays, right? So if we add it anyhow, right, if we add it anyhow, so this is going to be the minimum cost of the first subarray. Okay, this is fine. So now we find the one subarray's minimum cost, which is nums of 0, right? This is the first. What we need now, we need remaining 2 subarrays minimum cost. So we need to divide the remaining array with 2 into 2 subarrays, and we need to find its minimum cost. Okay, so what is the minimum cost? Minimum cost is nothing but first index of that subarray. Okay, manlo we have divided into this one and this one. Okay, now we have divided into, this is one subarray. Okay, my bad. Okay, so now this is one subarray, right? Okay, this is fine, this is fixed. So this is always fixed. For any given input, first index is going to be the minimum cost for the one subarray, right? That is fine, that is fixed for all the inputs. What we need to do now, we need to find the remaining 2 subarrays minimum cost in the remaining array from 1 to n minus 1. So we need to find 2 subarrays minimum cost within this range. Okay, so within which range? 1 to n minus 1 range, we need to find the remaining 2 minimum cost. Okay, now let's see. So if we have created one subarray like this, so it is going to be one minimum cost, and in the remaining one we need to find the another minimum cost. Okay, so what if we find the next 2 smallest elements in the remaining array? Did you get my point? So if we find the next two smallest elements, so if we find 2 smallest elements, we can create 2 subarrays from that, right? So let's observe this one. What are the 2 smallest elements in this array? 1 and 3 are the 2 smallest elements. So if we observe, with 1 we can create one subarray, right? With 3 we can create another subarray. So here length doesn't matter, and order also we didn't care about the order too. So if we found the next two smallest elements from that array, we don't need to create subarrays, or we don't need to generate the subarrays. We just need to find two smallest elements from the remaining subarray. Okay. Okay, let's see the pseudocode for this one. So how we can find? So first subarray's minimum cost is fixed for any input. It is nums of 0. So from in the remaining subarray, right, for int I is equals to 1 select a and I is less than n minus 1/3, right, we need to check two smallest element. Okay, how we can find next two smallest elements? So one is sorting the array, sorting the remaining array, and we can find the two smallest elements, right, which is going to take order of n log n, right? But there is one approach to find the two smallest elements in the array. So what is that approach? One approach is, so we'll take two variables called minimum 1, right, minimum 1 and minimum 2, right? We'll initially take them as infinity. Okay, inf. Okay, we'll iterate the array from index 1 to n minus 1. Okay. Okay, so now we will check if this index 1 3 is less than minimum 1. If it is true, then we will update the minimum 1. Before updating minimum 1, we need to make sure that minimum 2 is updated with minimum 1. Okay, so what we do is, if nums of I is less than minimum 1, then we will update the minimum 1, right? So we find a minimum 1, so we will update it nums of I. So before updating the minimum 1, we will update the minimum 2 with minimum 1. Okay, now if nums of I is not less than minimum 1, that means we found the second minimum, right? In this scenario, we will update just minimum 2 is equals to nums of I, right? Let's check this one. What is the remaining array? 3 comma 8 comma 1 comma 4. Now both are minimum 1 and minimum 2 are infinity. Let's take 3 is less than infinity, true, so we will update minimum 1 with 3 and minimum 2 with minimum 1, which is infinity again. Now let's go to 8 is less than minimum 1, false, so we'll update the minimum 2 becomes 8. Now let's go to the next element, which is 1. Is 1 less than minimum 1? True, so we have to update minimum 2 first, so we'll update minimum 2 with 3. We'll bring 3 here and we'll update minimum 1 with 1. We'll go to next element, which is 4. Is 4 less than our minimum 1? No, we come to else condition, we'll update with minimum 2. So here also we need to check that if minimum 2, if it is not less than minimum 1, we need to check if it is less than or equals to minimum 2. Nums of I is less than minimum 2. Then only we have to update minimum 2. Okay, so in this scenario, minimum 2 is already less than 3, right? 3 is not less than 4, so we will not update it. So we found the next two minimum elements. Now what will be the cost? We know already we find the first minimum cost, which is nums of 0, and then first minimum element, and then second minimum element, which is our answer. So we'll simply return it. Okay, let's see code for this one. So, we know that at least in the constraints they have given that we are going to have at least 3 elements in the nums array. So we are sure that we are going to divide nums into 3 contiguous subarrays. So we know that first element is always going to be the first subarray's minimum cost. So let's store that into first is equals to nums of 0, and then let's take two elements, int minimum 1 is equals to integer dot integer underscore max value, and let's see minimum 2 is equals to integer dot max underscore value. Now we have to iterate the nums array from index 1, right? Now let's write a loop into I is equals to 1 to I should be less than nums dot length and then I plus plus, and then we need to check if this nums of I is less than our minimum 1. If it is less than, then we'll update minimum to first to minimum 1 with minimum 1, and we'll update minimum 1 with nums of I. Okay, and let's in else case what we need to do, in else case we need to check if nums of I is less than minimum 2. If it is less than minimum 2 only, then update this minimum 2 with nums of I. Okay, at the end what we do is we'll just return the minimum cost is combination of this first plus minimum 1 plus minimum 2. Okay, that's it. Let's execute this now. Yeah, test case is accepted. Let's submit this solution. Yeah, accepted. Yeah, that's it. Thank you guys. If you like my content, please do like, follow and subscribe. Thank you, and please add this program's time complexity and space complexity in the comments. Please subscribe guys. Happy coding. Thank you. Bye.